Hello. Welcome to the final Fall 2025 Northeast Cover Crops Council webinar. I'm Victoria Ackroyd, NECCC Program Manager. My co-host is Susan Brulette, Program Manager for the Northwest Crops and Soils Program at UVM Extension. Before I introduce today's speakers, a little bit of housekeeping. If you have any questions, feel free to throw them into the chat as they come to mind, and I'll handle question and answer moderation at the end of the webinar. Today's session counts for one Soil and Water Management CCA CEU. To get credit, you either need to please email your full name and CCA number to Susan. I'll put her email in the chat, or you can just direct that information to Susan in the chat. This webinar is being recorded. It will be available soon on the UVM and NECCC websites. And now our speakers. Dr. Peterson is a postdoctoral associate in the Precision Agriculture Lab with the University of Maryland Extension. Her areas of expertise include precision agriculture, agricultural water and irrigation management, cover crops, and soil conservation. Dr. Carrijo is an assistant professor and extension specialist in grain crop production at Penn State. Her areas of expertise include corn, soybean, and small grains, sustainable intensification of agriculture, and water and nutrient use efficiency. Cara and Daniela, thank you for joining us today to talk about cover crops and water dynamics. Cara, I think we had agreed you were going to go first, and so you have the floor.
Great, thanks, Victoria. Thank you all also to the Northeast Cover Crop Council for inviting me and Daniela to speak today. So I'll be covering cover crops and soil water dynamics in the early part of the season, so particularly in the springtime. And I'm going to get started here. Oops. So just to kind of put us in the context, so the systems that I'm used to working in are in no-till conventional, mainly grain crops like corn and soybean. But I know that many of you might be coming from vegetable production systems or even orchards or vineyards. So I just want to acknowledge that I'm going to be speaking about cover crops in the spring, in the very early part of the corn season. But some of you might be more familiar with planting cover crops in the shoulder seasons or even in between two different vegetable crops, midsummer. So hopefully what I'll be speaking about with soil moisture and cover crops can also be helpful for those systems as well. So this is part of my dissertation research, and I studied cover crops and soil moisture in the early season. And just to overview of the general timeline, over winter we've got a cover crop and it's growing, and it doesn't really actually grow that much until later in the spring, until green up, when it puts on a lot of biomass. And then typically we terminate the cover crop. And in this system that's no-till conventional, that's typically done by applying a broad spectrum herbicide and possibly also adding on a roller crimper operation. And then in this area, I'm working in Maryland primarily. Typically, they plant the cover crop into the no-till residue, the cash crop into the no-till residue, and then we've got the cash crop. And in this example is corn growing through that cover crop residue during the rest of the season. And just to step back a little bit, why is it important to think about cover crops and soil moisture and soil water management in general? You're all here in a cover crop webinar. I'm sure that you all know a lot about the different benefits of cover crops, and there's a lot of them, but to focus on the water management side of things, that most of our crops get their nutrients from the water that they take up, that the nutrients are dissolved in the water, and that's how the cash crops take up their nutrients. Also, if you're working with cover crops, probably aware of a lot of environmental issues and the interactions with farming techniques. And so soil and water management has a big impact on the effects of farms on leaching and runoff into the natural waterways in our area, and then also those waterways that not only that we value for just their beauty, but also for the economics around fishing and tourism and many other industries. And then finally, on your own fields, paying attention to soil water management is important for the drought and flood damage mitigation when we have either too little rain or way too much rain, cover crops can be both a help and also possibly sometimes a hindrance in those contexts. Hopefully, more often, we can use cover crops to help us mitigate the effects of drought and flood, but that's another way that soil water management comes up in this discussion. And speaking of hindering soil water management, there are some concerns out there in farmers' conversations and in research about water management concerns with cover crops. One is that cover crops might keep the soil too wet and also too cold in the springtime. So it might delay cash crop planting, and it might keep your soils too wet in order to drive on with your farming equipment in order to get planting going in the springtime. And then also in drier areas where they really rely on the water that collects in the soil throughout the off season, throughout the winter, when that's really essential, just any little bit you can store up during the winter, when that's really essential for your spring cash crop, that can be a concern for farmers who are being encouraged to plant a cover crop. And there are studies that show out in more arid regions, like out west in the United States or places all around the world that don't get quite as much persistent rain or consistent rain as the Northeast area. Um, there are some studies that show that it can be a detriment to your soil moisture by planting a large cover crop over the winter. But here in the Northeast region, most often, what we see are the benefits of a cover crop residue on the soil moisture in the spring. And there's two kind of ways that this shows up in the springtime. One is, and as you can see on the left-hand side here, while your cover crop is growing, it's using soil water. It's using and pulling up the soil moisture and can actually help dry out your soil a little bit before you're trying to get in there to plant your cash crop. Also, after you terminate the cover crop, and assuming that you're in a no-till system, then that cover crop biomass, that residue stays on the soil surface and essentially acts like a mulch. And it therefore is reducing how much sun is hitting your soil surface and reduces evaporation of the soil water. And so it keeps it nice and moist. And that can be really helpful when you start getting into the warmer temperatures, especially in like June when the temperatures start heating up and your cash crop is starting to grow quite a bit. And it's early enough that you really are trying to make sure those new cash crop seedlings have all of the help they can get getting established. Another way that cover crops can help increase soil water content and aid with soil and moisture management in the springtime is that by, again, serving as that mulch layer, not only does it keep the water from evaporating off the surface, but acting like a mulch, it can reduce the speed that the water is moving across the soil. So when you have a really heavy rainstorm in the spring, here in Maryland, sometimes we still get really heavy rain in like June. It's not quite those big, heavy summer thunderstorms, but we can get quite a lot of rain in June. And so when you have a lot of rain coming down, when you have a residue on the ground, instead of just hitting the soil and possibly disrupting your soil surface, but then also collecting and running off really quickly, the mulch residue really slows that water down and it holds it, absorbs some of it, and then it lets the water kind of trickle off across and then also holds it in place for longer. So then it trickles into the ground instead of just washing away off the top. And so I wanted to talk about two specific studies or bring up two specific studies that I've done recently. And they, again, really zeroed in on this mid-spring, early summer period. So how does the presence of a cover crop residue and the biomass level, and then also even the termination method we'll get into a little bit, how does that impact infiltration? And infiltration is different than the concepts I was just talking about. So instead of looking at the soil water loss, it was like evaporation off the soil surface or transpiration, which is through the plant itself, when the plant itself is pulling up that water and then it's being lost through the plant leaves. Infiltration is when water is coming into the soil profile. And for these specific studies that I'll be discussing, I just wanted to define infiltration because depending on which scientist you talk to, this was like a good 10-minute conversation in a couple of different meetings I've had. So depending on the scientist you talk to, they might define infiltration differently. And I wanted to make sure that we're all on the same page with what I mean when I'm saying infiltration. So I'm using this term in the context of how much the soil water content increases within a certain amount of soil in response to precipitation. You could also maybe apply this to irrigation. Right now, in my new position, I'm learning a lot about irrigation. And so the data that I'll show you is from naturally occurring precipitation, but you can apply some of these concepts to irrigation as well. And this is just a numerical example if that helps you kind of envision, like we're starting with 15% water content during a dry season or dry spell, and then it rains, and then that water content goes up to 22%. So that's that difference in infiltration I'm looking for. So the first study I'll go over briefly, and I'm not going to get too much into like the methodologies of these studies, but I wanted to get into basically the findings of them and what they mean more applicably on your farm or for your own cover crop management. The first study that I'll discuss is a data analysis of soil moisture data that was collected all over the eastern half of the United States. So from each of these purple states, we collected soil moisture data, and I analyzed data from just the first 6 weeks after the cash crop planting. So again, that early summer, late spring time. And this was done with the Precision Sustainable Agriculture team, which is based out of the USDA site in Beltsville, as well as NC State and Raleigh. And that's why, of course, we have much more data from those areas. But I also want to note we got some data from up in Vermont, New Hampshire, Pennsylvania, Delaware, some other members of the Northeast Cover Crop Council. And I've got some data later on specifically from the Mid-Atlantic eastern side of things. And at each of these spots, they were all of these experiments were conducted on farmers' fields. So on a commercial grain production field where a cover crop of any kind was planted, and then there was a single no cover crop control strip where the farmer themselves either skipped a pass by planting or they sprayed out a pass. So just no cover crop was grown, but otherwise the farmer decided every other piece of the management, including what type of cover crops they planted. So this included all the brassicas, legumes, mixtures, cereal, rye. A lot of the sites were single species, mainly cereal rye, sometimes only clover. Another frequent mixture was, or a common mixture was, of course, like a cereal rye and a clover or a cereal rye and winter pea. But we didn't control for that. So it was just whether there is or there is not a cover crop on the ground. And these are some photos of what that looked like. Unfortunately, they're from the South, but I thought they were a good representation of what it looked like on the field. So on the left is what it would have looked like during the winter when you've got a no cover sprayed out and then a living cover on the side. And then similar setup, but with the spring cash crop. In this case, a corn crop. You've got no cover crop on the left-hand side, and then the cover crop you can still see is on the soil surface on that right-hand side. And again, I looked at the first 6 weeks after. And this is just an example of what the data looks like from one single field. So you can see this black line is the soil moisture, and each one of these bars on the bottom is a rain event. And so you can see how the soil moisture is slowly drying down, and then we have a rain event and it peaks, and then it dries down and it peaks again. So I analyzed each of these gray bars, which are one of these infiltration events, when the soil water content increased. And what we found out across all of these states, so this includes some pretty dry areas, some pretty wet areas, skews a bit towards the East Coast, but what we found is that infiltration, that soil water content increase, was similar in the no cover and the cover crop plots. Essentially, there was no difference in how much in each of these different rain events. There was no difference in how much infiltration occurred. But that was very different according to once you broke it down by geography, by soil type, by all of these other factors that we know are going on these farms, that not every farm is similar at all. So the biomass at termination was not a significant predictor of infiltration across this entire area, but that's why regional specific management really matters, because if you're talking to a farmer in, Kansas over here, it's going to be different than Virginia, than New Hampshire, than Wisconsin. So just to make the point, I kind of wanted to include all of the data we had available. And then I dialed down into different regions and I broke down the regions we had available. Unfortunately, I did not do a formal analysis of the soil moisture in Vermont and New Hampshire, and Pennsylvania kind of got put into the inland moderate climate region. But I wanted to just show you the results I got from the mid-Atlantic coast and the sandy soils, thinking that possibly if any of you are in sandier soils in like southern New Jersey or I think Rhode Island or possibly Massachusetts, hopefully this would be relevant to you. So in this mid-Atlantic region with very sandy soils and lower silt levels, we found that infiltration did increase with cover crop biomass at termination. So the more residue there was on the ground, the larger the above ground biomass, essentially the larger the cover crop plant was allowed to grow, the infiltration did increase on sandy soils. And my guess is that was because sandy soils dry down much faster than other soils. And so there was already a lot of pore space available for the infiltration to happen. But that infiltration also increased when you had a biomass, when you had a cover crop on top of it, because the cover crop could absorb the incoming rain, hold it for a little bit, and then release it into the sandy soil where there's lots of pore space to accept it. And that's different than if you have, biomass or residue on a heavier, a clayey soil or a siltier soil, because those soils hold soil moisture for so much longer than sandy soils do, that often it takes much longer for them to dry down. And when you have a rain event comes, there's actually just not enough pore space in the soil profile to accept much more water. So the soil texture can really either mute or accentuate the effects of a cover crop. And here in this example, it showed up in this one specific climate region with sandy soils. Now, the second, I'm going to run through the second study, and then I definitely want to hear some questions about any of these. So the second study that I wanted to discuss was about cover crop termination methods and how that impacted soil moisture, again, in the early summer, in like the first 6 weeks or so after the cash crop planting. And here we compared both mechanical and chemical methods. So I compared, there was some cover crops were roller crimped and some were not. They were just left standing. And I'm hoping that maybe there's some organic farmers on here who use cover crop roller crimpers, or maybe you're a conventional farmer who also uses roller crimpers as in addition to maybe spraying, or on just another way to kind of lay the cover crop biomass down neatly in the field to help with your planting in the springtime. But we combined the mechanical method, this roller crimper, with chemical termination methods. So if you're a conventional farmer, you're probably more familiar with these. We compared glyphosate with paraquat, mainly because they're both broad spectrum herbicides, but glyphosate takes anywhere from 1 to 3 weeks to really kill the plant, versus paraquat usually within like 48 hours. And you often see the results of spraying within hours after they're sprayed. And these two are not the only herbicides that are used to kill cover crops, but they're one of the more common ones, and ones that were already being used on the research fields that we were using. So this is what the field plots look like. This is just one replication of the experiment that we did at 4 different sites. So in each one, there would be something that was standing. There would be cereal rye that was standing and sprayed with glyphosate, and then cereal rye that was rolled and sprayed with glyphosate. and then sterile rye that was standing with paraquat and rolled with paraquat. We also had in these fields no cover crop controls, and then also plots that were just covered with straw as something to compare the cover crop, which had been growing in the field and taking up soil moisture as it was growing, versus straw that's just, an inert residue just on the ground, hasn't been transpiring, at least not that we think of, unless it gains some kind of, never mind. So this is what the soil moisture looked like at these 4 different locations. And something that's really important to note is the difference in years and the difference in sites. So in 2022, both of these sites, we had a lot of rain during the experimental period. So the soil moisture, which is all of this lines, these are all the soil moisture data coming from the different cover crop plots. Because there was so much rain, the soil moisture stayed very high. Then the next year, we had a very long drought period in which most of Maryland actually was classified officially as being in a drought through mid-June. And you can see this long dry down period. And the gray and the black lines are the no cover and the straw plots. And all of these lines that have color, they're blues and oranges, those are all of the cover crop plots that were killed differently. And the main takeaway that I really wanted to impart here is that it didn't matter very much at all how we killed the cover crop, but what mattered was the presence of a cover crop, if there was any actual residue on the soil or not. And also, just for context, so this was a cereal rye cover crop, and we killed it fairly late in the season because we were using the roller crimper, which you might know you need to wait until the cereal rye reaches maturity, until it starts losing its anthers, until it hits anthesis. You have to wait until the cereal rye hits that maturity stage in order to effectively roller crimp it. But that means that you're keeping the cereal rye in the ground much longer than you would otherwise for a cover crop that you might only spray out or terminate in some other methods. And the last thing I wanted to point out here is that what you can also see is that so in the beginning of the soil, I mentioned in the beginning of the spring, I mentioned at the beginning of my presentation that in some areas, cover crops can use up soil moisture as they grow, and that can be a concern for farmers in drier areas or during dry years. So here you can see a similar pattern happening where the gray and the black and the gray and the black in both of these sites, um, those are the straw and the no cover crop plots, and they have higher soil moisture. They stay they have more water at the beginning of the season versus down here, you can see that all of the plots that are colored have lower soil water content, presumably because the cover crops, which are at this point a very large cereal rye, which is transpiring a lot, um, you can see that it's starting at a lower soil and water content point. However, we did go through this dry period, but then we have several rain events, which are all of these gray bars at the bottom. So it rains and then it rains. And then by the beginning of July, when we're starting to enter the really, really hot summer season, the soil water content is essentially the same. And that's the effect of what you can see when you've got the residue on the ground in the spring, that it can help keep the soil moisture that's in there, and then also help increase the water that actually infiltrates into the soil profile. So even though we start at a deficit with the cover crop, by the end, after some rainfall, it evens out and you have effectively the same soil water content. So I'll wrap up there because I wanted to give Daniela plenty of time for her presentation. And so I'm happy to hand it off to her.
Thanks, Cara. Let me try to share my screen here. Um, okay, can you see my full screen now?
It's not in full screen mode. unless you mean to show to both the current and the next slide at the
Okay.
same time. There you go.
Maybe I need to do that. Okay. Move it this way. All right, cool. Yeah, thanks everybody. That was a great segue, Cara. Very, very nice to hear, to see your results there, and great segue to what I'm going to talk about, because we're moving on from those early soil moisture dynamics to late season dynamics with cover crops. So it's great that you talked a little bit about kind of the general management practices and how cover crops fit into our systems here. We're in Pennsylvania, so very similar to Maryland. So I'm going to go straight into this case study that we did in soybeans a couple of years ago. So in general, you know, as Cara is talking about, when we have a cover crop growing in the spring, it's taking up that water, usually drying out that soil. And then as we terminate that cover crop before the planting of the cash crop, in this case soybeans here, that residue of the cover crop that's going to be degrading in the field tends to act like a mulch, right, on that soil surface. So it's helping us conserve water mid to later in the season. And this is what we were really interested in looking at with this study is, you know, how can you quantify this mulch effect? How big of a deal is that? Is it really significantly helping us reduce the drought stress that that cash crop, in this case soybeans, are experiencing? And does that translate to yield at the end of the day? And as we think about that mulch that cover crop acting as a mulch, you know, intuitively, the bigger that mulch layer, the bigger that effect. And so as we think about how can we maximize our cover crop biomass at termination, there are a few things we can do. Thinking back in the autumn or in the fall, of what things we can do with that cover crop. So, you know, back in the fall when we're planting that cover crop, we can plant it early in a very timely manner. We can increase that seeding rate, put some fall fertilization there. All of that will help increase that cover crop growth in the fall. Now, early planting with cover crops, that can be tricky. A lot of times that cover crop is coming after harvesting you're putting that after harvesting a cash crop, sometimes corn, for example, and that doesn't get harvested until late or whenever you can do that. So you're depending on other things happening in the field. Increase the seeding rate and putting on fertilizer, that also implicates in costs, right? You're gonna have to spend some money on that. So a lot of times those things don't happen as you like. And going over into the spring, you also again have another opportunity here to fertilize that cover crop, maybe put a little bit of nitrogen on it to push that growth early in the spring. But again, associated with the cost here. So a lot of times what happens is the last resort here that we have to maximize our cover crop biomass is to delay that termination. And there's basically two ways you can do that, right? If you were not planning on like terminating that cover crop about 2-3 weeks before planting your soybeans, you can switch on your termination method, and instead of terminating that cover crop ahead of planting your soybeans, you can plant green. So you delay that termination of that cover crop until close to the day off, or even right after the soybean planting. If you don't want to do that, or if maybe you're already planning on planting green, well, the only other thing you can do is delay everything, which means delay the planting of the soybean crop. Now, that gets a little bit tricky because, as a lot of the soybean farmers are aware of, with delayed soybean planting, usually we're seeing a decline in yield potential of that crop. So this is just a map that I like to show with showing the yield difference between if you plant your soybeans on May 1st to delaying that to May 31st at the end of the month. And overall on the northern part of the US, we see that yield decline and that yield potential, and just bulk average here for our state of Pennsylvania, we're expecting about an 8% lower yield potential as we delay that soybean planting by a month. So that's usually the conundrum that we're facing here when we're thinking about, okay, how can I maximize my cover crop biomass, but I also want to plant my soybeans early. And so this was the core of the study the study questions that we wanted to address here. So kind of question number one is more generic, like if we have more cover crop biomass, does that lead to that soil moisture conservation late in the season, and does that more importantly lead to that higher soybean yield? And then the second question is, when we're in that conundrum between planting early and maximizing your cover crop biomass, is it worth delaying soybean planting to realize this benefit of soil moisture conservation, assuming that's true? So we set out some studies, and Navdeep Kaur is my PhD student. She's in her final year now, and she led this field trial. So we had 3 site years, 2 in central Pennsylvania, 1 in southeast Pennsylvania. Her paper just got accepted, so I don't think it's online yet, but maybe in a few days. If you're curious to look more into the details, you can just type this title and hopefully find it there online. So here's what we did. So we compared 4 treatments that were mixtures. In all 4 treatments, we had cover crops. I wanted to mention that. And those were either triticale or cereal rye, depending on the site year. In all 4 treatments, that cover crop was planted on the same date and within the site year, planted on the same date in the fall. And then the difference here is we had combinations of 2 different termination timings and 2 different soybean planting dates. So in this early planting treatments here, the soybeans were planted on the same date. And that was, I want to say, the beginning of the ideal planting window of each location. So nothing too extreme, right in the beginning of that planting window. And then with late planting, those soybeans were planted near the end of that planting window. Typically, this would happen about 2 to 3 weeks after the early planting within each site year. And then the termination timing, it was either planted brown. I'm going to use this term here because we have early and late planting. It gets really confusing. The planting brown means we're terminating that cover crop 2 to 3 weeks before planting the soybeans. So this is one case where we're terminating the cover crop here. We have this period here where nothing's going on before we plant the soybeans. Same thing in this treatment. And planting green, that's the case where we terminated the cover crop right after planting the soybeans. So on the same day, that was all chemically terminated with glyphosate. We had a roller creeper also going on at the same time. That was done with the research planter that actually has a roller creeper attached right in front of the row units. So that was all done in the same pass. So part of this was, as you can imagine, with looking at the length of those bars here, those cover crop bars, as you go from the early planting brown treatment to the late planting green treatment, we're increasing the time that cover crop has to grow in the field. So we're expecting, higher biomass of that cover crop by termination time as we go from the top to the bottom here. Get past this on. There you go. So, okay, this is a lot to look at, but this is just showing the cover crop biomass. Those are in the at termination. So those are the bars here in the graph. We have the 4 treatments at the bottom. And each one of these is a trial location. So this is Southeast 2022, Central Pennsylvania 2022, and Central Pennsylvania 2023. So our 3 field trials here. And as we expected, as I just mentioned, if you're looking at those bars, we're seeing kind of this trend of increasing biomass at termination, going from that early planting brown treatment, which was the earliest to be terminated, to the late planting green treatment. I would say this cases here where the middle treatments are kind of similar. That was because the termination time of that cover crop ended up being very similar, like same day or the next day, just because of the rain patterns and planting windows we had. So it really followed, the more time in the field, the more biomass, which is what we would expect. And I just wanted to point out the ranges here. So, with that early planting brown, we're looking at about half a ton of biomass per acre, so not a whole lot. And with the late planting green, we're seeing about anywhere between like 1.5 to 3 over here. So quite an increase, but I wouldn't say nothing too crazy in terms of biomass. On this side of the axis, that's the carbon to nitrogen ratio of the cover crop. So again, also as we expected, this is the line graphs here, and as we're going later in the season, like more time for that cover crop growth, that carbon to nitrogen ratio is also increasing as we expected. Okay. So let's go into soil moisture data. So, because that's what we're interested in. We monitored in all of those plots in those field trials. We monitored soil moisture using these multi-profile probes here, which were pretty handy because we get like different soil depths with those, and they went all the way to 2 feet underground. So from soil surface to 2 feet below the soil surface. This is our Abby, our student, who was helping out on this day. This is not how we installed those, by the way. This was a failed case where we had to dig this soil probe out of the ground, which was super fun. All right, so looking at soil moisture data, I'm just going to show one case here. So let's walk through this. This is soil water content. This is the first foot soil depth, and I'm just showing this because we really didn't see many differences across the different depths. So this is kind of representative of across that 2 feet soil profile. This is the early planting soybeans, and then here we have time. So we monitor that soil moisture over time during the soybean growth. This arrow is when the soybeans were planted. And so here's the early planting case, late planting case. This was one site year, that was the Southeast 2022 field trial. So what we saw here in this one trial, we didn't see, oh, I forgot to say the green is the planting green treatment, and the brown here is the planted brown. And so when we planted the soybeans early, you see those lines are overlapping here, which means soil moisture was not different between those 2 treatments. Now, when the soybeans were planted late, we see that planting green actually conserved that water, and we see the higher soil moisture around that mid to late season, so August, September, when things are getting really hot and dry here in Pennsylvania. So we're seeing here this mulch effect of soil moisture conservation with the planting green treatment that had more cover crop biomass at termination compared to the planting brown treatment. Now, this only happened in one site year, so I can tell you that if we looked at these graphs for the other 2 remaining site years, those trends are all overlapping. And so meaning soil moisture was the same, and we didn't see this soil moisture conservation effect in those other 2 years. But so going back to our study questions, is more cover crop lead to soil moisture conservation late in the season? That only happened in 1 out of the 3 years, right? Site years, just in that one case. But we were thinking about, well, what about the soybean plant? Maybe we're not seeing those differences in the soil because the plants are actually taking up that water. And so we wanted to see kind of how the plant was actually feeling. So we did another measurement of soybean drought stress, which I'm just going to walk you really quick through this theory here. We measure the carbon-13 ratio of the soybean grain. So the way this works is when plants are using that carbon dioxide that's in the air, right, for photosynthesis, that carbon dioxide, that carbon in the CO2 molecule can be either carbon-12 or carbon-13. The carbon-13 is a heavier isotope, and so plants usually prefer to use the lighter isotope, the carbon-12, because it's lighter. It's easier for them to use that carbon in photosynthesis. Now, when the plants are happy and they're transpiring, there's lots of CO2 going into this leaf here. The plants are just they have the luxury to, pick out always the lighter carbon because that's what they prefer. Now, when they're not happy, when they're water stressed, they're not transpiring very much. They're going to close that stomata here, and then we're going to have a lot less CO2 available going into this leaf. And then at that point, they don't have that luxury of picking out the lighter carbon anymore. So they're going to start using more of that heavier isotope and incorporate that into tissue, eventually into the soybean grain. And so the theory behind this is if the plants experience a lot of drought stress, they'll have more of that heavier isotope in the tissue, in this case in the grain, which will reflect a lot of that grain filling period, which is really important, right, for drought stress and yield. Whereas when they're not water stressed, they'll have more of the lighter carbon isotope. So we did those measurements in all of those field trials, and we saw a response across all of the site years. So for the early planting brown treatment, that was where we had the lowest cover crop biomass at termination. Soybeans were generally significantly more stressed than in the treatment of the late planting green treatment, which was the one where we had the highest cover crop biomass at termination. And we're kind of seeing a little bit of a trend here, right? So we saw the significant difference across all of the site years. We also looked at correlation. So when we looked at that cover crop biomass, it was significantly correlated with that drought stress measurement, meaning the lower soybean drought stress, the higher cover crop biomass at termination, the lower those soybeans, the lower drought stress those soybeans were experiencing. And then I'm going to show the yield data in a little bit, but we also saw a correlation between yield and that drought stress measurement, meaning that when soybeans were less drought stressed, they also tended to yield more. So that was a yield driver. So, just from this correlations and that drought stress analysis, going back to our study question number 1, we're seeing that, well, yeah, more cover crop biomass tends to lead to that soil moisture conservation and less soybean drought stress, and eventually higher soybean yield. That seems to be the case from this data. And one thing I wanted to really quickly touch on here is just remind us of the biomass that we had for those treatments. We had, half a ton or less in the early planting brown treatment, and then that late planting green, which was the highest biomass, we had on average about 2 tons per acre, which is not a whole lot of biomass, I would say. The other thing is, across all of those trials, that C to N ratio was always higher than 15, which means it could be a a big deal in terms of how um, how long that tissue, that residue is going to take to degrade in the soil, which I think plays an important role of conserving that soil moisture. It's keeping that mulch in this um, uh, more lignified tissue for a longer period of time and keeping that soil moisture in the soil. And when we look at carbon to nitrogen ratio higher than 15, really we're seeing as we think about cereali and triticale in that case, we're not going to reach that until we're at the end tillering phase or stem elongation phase or later. So it's possible that if you have a grass that only has 1 to 2 to 3 tillers, maybe that's not enough to see this benefit that we saw here. Oh, and just a visual on that. I wanted to show the late planting green. This is how it looked. So you see this residue here is totally present. Those soybeans are at the grain filling stage, whereas with the early planting brown, you don't even see the residue anymore. It has been totally degraded. So, and answering our second question, which is really the core of it, was, is it worth delaying soybean planting to realize this benefit? And so let's look at the yield data. To answer that question about is it worth delaying, we can compare this late planting scenario with the early planting brown, which is kind of our control with the lowest cover crop biomass. And what we see here is, in all of the cases, we did not see a yield penalty as we delayed soybean planting, along with more cover crop biomass at termination. And in this one case here, in one field trial, we actually saw higher yield with late planting green treatment compared to that early planting brown. So to answer that question, at least based on this 3 field trials, which I think that's a very regional question to ask when you're looking at those planting the 8 effects and all of that. But at least based on that data and for central and southeast Pennsylvania, the answer is yes, it was worth delaying that soybean planting to realize that benefit of conserving soil moisture. Because in 1 out of those 3, right, we had a yield increase, and we never had a yield penalty with delaying soybean planting, along with increasing that cover crop biomass. And the last thing I wanted to point with the soybean yield data is that early planting green treatment, across all of the trials, it was the highest yielding, absolute highest yield, right, across all of those treatments. And to me, what that indicates is this treatment is kind of getting a little bit of both worlds. We're having a little bit more cover crop biomass compared to the early planting brown, but then we're also experiencing the benefits of that early planting that we typically see. So that was interesting to see kind of across all of the field trials. So some key takeaways of that was that benefit of higher cover crop biomass to reduce soybean drought stress. We saw that it is indeed the yield driver, and that happened even at, like I said, relatively low biomass levels, about 2 tons per acre. It's funny, this is, I think, what we typically see for yields or weeds, reducing weed pressure. We want to see something like that as well, or higher. And then those C-to-N ratios, this is not something we tested, but across the board, they were all higher than 15. And I think this might be an important characteristic to keep in mind. And then at least here in the central and southeast PA, what we saw is it really justified to delay that soybean planting for a couple of weeks to get that benefit. And I want to emphasize here that we're not talking delaying planting for extreme dates, right? We're talking within still within that optimal planting window, but just delaying it for a couple of weeks along with increasing, just to allow that cover crop biomass to increase. And with that, I wanted to thank our Pennsylvania Soybean Board who funded this research, our farm crew who really helped with all of those field trials, and our Penn State Extension agronomy team, our field and forage crops team, who really helped us with a lot of that work. And I think we have time for questions for both of us, hopefully. Well, a
Indeed.
little bit over.
Nope, you're good. You're both good. Thank you both, Cara and Daniela, for great presentations. I do want to remind the group, last reminder, today's session does count for one CCA CEU. If you need that credit, please go on ahead and contact Susan Brulette with your name and full name and your CCA number. So with that said, if anyone else has any questions, there's two in the chat, but feel free to be typing them up right now, or we can certainly just say unmute. But to begin with, I think there's two that were for Cara. So Cara, John asks, would the rolling interfere with the transport of glyphosate to the roots of the cover crop and effectiveness?
Yeah, great question. We weren't testing as much the effectiveness of the different termination treatments, but I can testify that just observationally, all of the cover crop plots were like completely terminated. We didn't get in any of the plots like any of the cover crops kind of there's a term for it, but when they pop back up again and they start growing and you haven't fully terminated them. So we didn't see any of that, like reemergence. But I know if you're interested in that there's definitely some folks who are testing all of the different termination, like herbicides especially, that are commonly used. So I know Mark Van Gessel is a common one, and then I think Michael Flessner, and some other folks probably. Yeah, so I'm not a weed scientist as much, so I don't test out that, but that's a good question, and I've heard similar questions in the past about that.
Thank you. And then Myra asks, what was the organic matter percent on the sandy soils? Does OM even matter to where you measured soil moisture?
Yeah, another great question. Um, I I'm trying to remember because I'm pretty sure I analyzed infiltration by the organic matter on the soils. Um, I'm just trying to see if I have it in this little. I don't. I was looking at the chart that I had of my different results, and I don't believe that the organic matter really there was any difference in the infiltration among organic matter, but it was more in the soil texture, and the sandy soils tend to be lower in organic matter anyways. So it could be there could possibly matter. I bet, with increased organic matter, typically soils have a higher soil water content. But I didn't exactly and analyze this organic matter. But I would bet that with higher organic matter would be higher soil water holding capacity. Yeah.
Awesome, thank you. Daniela also chimed in about that first question. John Wallace at Penn State is working on herbicides and roller crimping and does seem to have seen some decrease in effectiveness of some pre-emergent herbicides, but not on the cover crop termination itself. So with that said, I mean, I'd like to open the
As
floor.
best as I remember, but yeah, I know he's working on that,
Yeah.
so you guys could check with him.
Thank you.
Yeah, and that's a good point too, is the difference in some folks are working on how well it terminates the cover crops, and then there's the weed science part of it, is whether the cover crop management impacts your weed population going into the season. Yeah.
Yeah.
Yep. Other questions? Feel free to just unmute or raise your hand or Willie comments that there are so many factors as to the effectiveness of various herbicides to answer generally. Zach Larson. Hey, Zach. Cara, can you please compare and contrast your definition of infiltration with water holding capacity, as infiltration is typically a unit time measurement?
Yeah, great, Zachary. Thanks for bringing that up. That's always a good point of conversation. So the studies I was showing, the data I was looking at was in Exactly, the infiltration. So I define that as the change in soil water content in response to a rainfall event. So, right, soil water holding capacity is like a longer term characteristic of the soil itself, of how much water can be held within the soil pores. And the way that impacts infiltration is because if the soil has a higher water capacity, it tends to hold on to the water for longer and the soil will drain slower. And it's a little bit of a mind trick, but because the soil is holding onto water, the data might not reflect that there's higher infiltration because there's more soil water already in the soil, and therefore there's not much space for incoming rain to come into the soil profile. So that might be seen if you are having plenty of rain during like over a couple of weeks. It might show up in the data as the soil water content is not changing very much in response to rainfall. Then that's not necessarily a bad thing because there's already water in the soil versus soil that has a lower holding capacity, lower water holding capacity because it probably drains and usually has less water in general. When you do get rain, that water content increases, and so it might be reflected in the data as higher infiltration. So that's a great point to make, Zachary, of the difference between like the soil characteristics itself versus how much the water content is changing like in a single time. Yeah. And another thing I got into with this research was cumulative infiltration, of summing up the infiltration over the course of the whole season or over the course of like 6 weeks versus the individual events. And that's when we got into a big discussion about the change in water content over time versus in like at just certain time points. Yeah.
Thank you. Everybody says, thanks for your work and concise presentations. Kudos to both presenters. We do have 2 minutes left if there's any other questions. Otherwise, we can call it a day. I think general agreement is let's call it a day. Cara and Daniela, thank you so much for joining us and speaking, and thank you everybody who's been on these presentations. We are recording, they will be posted. It's been a great webinar series, and I much appreciate everybody for attending, Susan for setting up the logistics and helping me to run these, and of course our speakers for doing such a great job. I'm gonna go on ahead and hit
Thank
stop
you.
recording. Here's my stop recording.